This is lesson 19, the integrated rate law. So we can change rate expressions into equations that can relate our initial concentrations to the concentrations at any other time. And these equations are found in your data tables, but they're derived from calculus, so you don't need to know how they're derived, just what they are. So for a first order reaction, okay, the integrated rate law looks like this. The natural log of A at any time minus the natural log at the initial time 0 equals negative kt. And we can recombine this equation so that we get the natural log of A at any time equals negative kt plus the natural log of A naught. So we've just rearranged that equation. So using this equation, we can see that if this is y equals mx plus b, if we graph the y-axis, the natural log of A, versus the x-axis, which is t, so if we graph the natural log of our reactant versus time, we will get a straight line, and the y-intercept of that line will be the natural log at the initial concentration of A, and our slope will be negative k. So our y-intercept again is the natural log of our initial concentration. So using this graph, we can find our initial concentration, or we could also find k for this reaction. For a second order reaction, our integrated rate law is going to be 1 over the concentration of A at some time equals kt plus 1 over the initial concentration. So if we graph this, y being 1 over the concentration of A and x being t again, we will get a straight line if it's a second order reaction, and the y-intercept will be 1 over the concentration of A, and our slope will be equal to k. And finally, if we have a zero order reaction, remember it doesn't matter how much reactant we add. Our integrated rate law is the concentration of A at any time is equal to negative kt plus the concentration of A at the initial time 0. So if we graph this one, again y will now be the concentration of A and x will be t. We will get a straight line, and the slope of that line will be equal to negative k, and the y-intercept will be the initial concentration of A. So the integrated rate law is very important for finding the concentration at some time, or finding the initial concentration, or finding k. If we have a first order reaction, our half-life, or the time it takes for half of our reactants to react, is always going to be equal to negative natural log of 1/2 over k, which is always equal to 0.693 over k. It does not depend on the initial concentration. It remains constant. So there's no concentration in here. The half-life will always be 0.693 over the rate constant.